Good afternoon, everybody. I am going to start measurement of angles. Measurement of angles. Before we start the measurement of angles, I will explain you some definitions. So, how we describe a positive angle and how we describe a negative angle, I am going to describe that. Positive angle. Now you see, let OA is a line in initial position and OA rotates about A in anti-clockwise direction. Anti-clockwise direction. Anti-clockwise direction. And it reaches to a terminal position OB. Angle AOB described in this way is known as positive angle. Now you see, this is the initial position of the line. This is the initial position of the line. This is OA. OA is rotating about O. OA is rotating about O in anti-clockwise direction. So it reaches to a terminal. This is initial line. This is terminal position of the line. So in this way your angle AOB is described, and this described angle AOB is known as positive angle. So now next point is to describe the negative angles. In negative angles, in clockwise direction, let OA is an initial line, OA is a line in initial position, and OA rotates about A in clockwise direction. In clockwise direction, its terminal position is OB in this way. Angle described, angle AOB described is called negative angle. Is known as negative angles. This is your initial position of the line, and this is your terminal position of the line, and your this angle described is negative angles. Now next thing, now I come to measurement of angles. We can measure in so many ways, but the ways we measure that is in our course is degree measure and radian measure. Degree measure of the angle, and that is also known as sexagesimal. Sexagesimal measure, degree measure is known as sexagesimal measure, and next one is radian measure. Radian measure is also known as circular measure. This is known as circular measure. In degree measures, the angle are measured in degrees. Like a right angle is equals to 90 degree. And we represents our 90 degree in this way, right 90 and raise one small 0 above it. At a right angle is represented by 90 degree, and 1 degree is equals to 60 minute, and 1 minute is equals to 60 second. This is the degree measure of the angle. And now radian measure, how we define a radian measure. So if an arc of a circle subtends an angle theta at its center, if the center of the circle is O and radius are OA and OB, that is represented by R, your arc length AB is L, and the angle subtended by this L at the center is called angle subtended by the arc at the center, and this angle AOB, the angle defined in this way, is called radian measure of the angle. Radian measure of the angle is defined as the angle subtended by an arc of length L whose radius is R at the center. That is called the radian measure. So if this angle, let this angle AOB is theta. How you define radian measure? Radian measure is defined as the angle subtended by an arc at the center. Here I have taken angle AOB is theta. So this theta is defined as arc length AB upon radius of the circle. So in this way, if your arc length is L, theta is equal to L by R. L by R is the angle subtended by the arc at the center, and that is called the radian measure. This theta is measured in radians. This is called radian measure. Now condition is that when this radian measure of the angle becomes 1 radian. How will you define 1 radian? I am going to define 1 radian. How we define 1 radian? How we define 1 radian? So in this result number 1, in result number 1, when we take R equals to L equals to R, means arc length, that is arc length equal to radius. Arc length equal to radius. So in this way, theta can be written as R upon R, theta becomes 1, and this is called 1 radian. 1 radian is denoted by 1 to the power c. 1 to the power c or 1 radian. This c is taken from the first letter of the word circular measure. This symbol c is taken from the first letter of the word circular. So 1 to the power c means 1 radian or 1 radian. And 1 radian is equals to 57 degree 16 minutes. You remember this. So in this way I have defined your radian measure, degree measure, and now I am going to tell you how we change, what is the criteria, what is the condition under which we can change the degree measure into radian measure. To change degree measure to radian measure, in order to change degree measure to radian measure, we should multiply given degree measure by pi upon 180. This multiplication in degree measure will change it into pi radian, and by substituting the pi equal to 22 by 7, we can change that into radian. So now next thing is that one basic thing, your pi radian is equal to 180 degree. Pi to the power c equal to 180 degree, then 1 to the power c equal to 180 upon pi. 1 radian is also defined as 180 upon pi. And when you substitute the value, how you can show your 1 radian is 57 degree 16 minute approximately. This is the approximate value of 1 radian in degree. So how can you say? From this relation, pi radian is equals to 180 degree, 1 radian is 180 upon pi. When you substitute pi equal to 22 by 7 in this result and simplify, so you will get this as 90 into 7 by 11, 630 by 11. Now you divide 630 by 11. You find 11 5 is 55, 80, 11 7 is 77. 3. This is 57 degree. Now you have obtained 3 degree as a remainder. This is 3 degree as a remainder. 1 degree is equal to 60 minutes. 3 degree equal to 180 minutes. So again you divide your 180 minutes by 11. 11 1 is 11, 70, 11 6 is 66. Again your remainder is, this is your quotient is 16 minutes and your remainder is 4 minutes. So in this way 1 radian is equal to 57 degree 16 minutes approximately. In this way we can find the value of 1 radian in terms of degree measure. 1 radian is equals to, consequently we can write 1 to the power c, 1 radian or 1 radian, that is equal to 57 degree 16 minutes approximately. This is the approximate value of 1 radian. So now I have given you, in order to change the degree measure into radian measure, we multiply the given degree measure by pi upon 180. So you change 60 degree into radian. You change 60 degree into radian. You have to change 60 degree into radian. So 60 degree can be written as 60 multiplied by pi upon 180. You cancel that, it is equal to pi by 3 radian. This is pi by 3 radian. So another things, in order to change a radian measure into degree measure, we should multiply radian measure by 180 upon pi. For example, change pi by 4 radian into degree. So what you do? You write pi by 4 equals to pi by 4 multiplied by 180 upon pi. Pi and pi will be cancelled. You cancel that. This is equal to 45 degree. So in this way we are changing degree into radian and radian into degree. Now you see some specific change. There are some specific angle Their measures in degree and rotation, radian are given. Your degree and radian. 30 degree, 45 degree, 60 degree, 90 degree, degree and radian. Here again your degree is 120, 135 degree, 150 degree, 180 degree and 270 degree, 360 degree. So you notice that when you do all the calculations which I have given you earlier, so 30 degree in radian form is pi by 6, this is pi by 4, so by using that you can write this is pi by 3, this is pi by 2, this is 2 pi by 3 and this is 3 pi by 4 and it is 5 pi by 6. It is 5 pi by 6, this is pi, this is 3 pi by 2 and this is 2 pi. 2 pi is the complete one revolution. When a moving line makes a complete one revolution, the angle subtended by angle described by the moving line is 360 degree or 2 pi radian. So you must remember that after 2 pi there is again a rotation of the moving line and it will reach to different quadrants. I will tell you about the quadrants later on. Now next thing is that this word trigonometry is defined from the 3 letters of the Greek words. There are 3 Greek words, tri. I am talking about 3 Greek letters. These are Greek letters, tri. Another is gonio. Gonia. Tri, gonia and metron. M-E-T-R-O-N. There are 3 Greek words. Tri, gonia and metron. Tri means 3. Meaning of this is 3. Gonia means angle. Gonia means angle. Metron means measure. Now these 3 words implies that the measurement of, you can say in words, in one words, triangle measure. You can say this is triangle measure. These are the 3 words of Greeks, tri, gonia and metron. Tri means 3, gonia means angle, metron means measure. So this implies that the triangle measure. So actually in trigonometry what you are doing, in a right angle triangle you are measuring different sides and the angles, perpendicular, hypotenuse, because all the trigonometric functions are defined as a ratio of perpendicular, hypotenuse and base. So in this way you are measuring the triangles. So by 3 Greek words, tri, gonia and metron, trigonometry is derived and it named as trigonometry. This is trigonometry. Now I am talking about quadrant. There are 4 quadrants. We have studied that in coordinate geometry. Quadrants. in coordinate geometry, you have seen when two mutually perpendicular lines, one is horizontal and another is vertical, this is divided into four parts, and this first part, in which x and y both the coordinates are positive, is the first quadrant. This is first quadrant. This is first quadrant. And here this is second quadrant, in which your x is negative and y is positive. This is your third quadrant, in which x is negative, y is negative, and this is called fourth quadrant. And in which x is positive and y is negative. So this is the sign convention of the quadrant, so and that is used. Now there is some questions. Find the quadrants in which the following angles lies. With the help of that, find the quadrants. This is the question. Find the quadrants in which the following angles lies. So now you see that your first angle is 45 degree, second is 120 degree, third is 200 degree, fourth is 300 degree, and fifth is 500 degree, and sixth is minus 60 degree. You see that. Here you know that when a moving line moves, so quarter of, when it completes the quarter of the revolution, in that case your moving line OA is toward this position, and here the angle described by this is 90 degree or pi by 2. When it reaches to this position, so your angle described by this is pi or 180 degree, and here this is 270 degree or 3 pi by 2, and when it reaches here 0 degree or 360 degree, or you can say that this is 2 pi. So in this quadrant, your first quadrant is taken from 0 degree to 90 degree or 0 radian to pi by 2 radian. Similarly, second quadrant is from 90 degree to 180 degree, or you can say from pi by 2 radian to pi radian. Similarly, your third quadrant is from 180 degree to 270 degree, are from pi radian to 3 pi by 2 radian. You remember that? In such questions, these ideas will help you. So now in fourth quadrant, it is from 270 degree to 360 degree, or you say that it is 3 pi by 2 radian to 2 pi radian. These are the measures of the quadrant, and according to this rule, you find the quadrant in which the given angles, in this question given angles lies. Here one of the angle is negative angle. So from the initial line, when it's rotate about O in clockwise direction, then angle is negative. So your minus 60 degree, your minus 60 degree is in fourth quadrant. Now first 45 degree is in first quadrant. Second 120 degree, it is from 90 to 180. So this is in second quadrant. Third 200 degree, it is from 180 to 270. Therefore this is in third quadrant. Fourth is 300 degree. This lies, it is from between 270 and 360. So it is in fourth quadrant. Now fifth 500, it is more than 360. 360 plus 90, 540. So this is between 360 and 360 plus 90. So in this way, this is in first quadrant, and sixth minus 60 degree is negative angle. Therefore, it is in fourth quadrant. So in this way, you can decide the given angles lies in which quadrant, and you can answer that. Now another question. Express your question is express 5 degree 37 minute and 30 second in radian. That is the question. You have to change that in radian. So now you see, in this angle there are three components. One is the complete degree, that is 5 degree. Another second component is 37 minute, and third component of this angle is 30 second. So I have to change the whole thing as a degree first. So 30 second is equals to 30 upon 60, this much minute, and that is equals to 1 by 2 minute. Now 37 minute and 1 by 2 minute can be written as 37 and a half minute. That is equals to 75 by 2 minute. So now you see that 75 by 2 minute can be written as, this is equals to 75 by 2 divided by 60 degree. 75 by 2 divided by 60 degree, that is equals to 15 5 is 75, 15 4 is 60, that is equals to 5 by 8 degree. So in this way you have 37 and half minute is equals to 5 by 8 degree. So now you can write 5 degree 37 minute 30 second is equals to 5 plus 5 by 8 degree, that is equals to 8, 5 is 40, 45 by 8 degree. So first of all I have changed that as the given degree measure as a degree only. So this 5 degree 37 minute 30 second is equal to 45 by 8 degree. So now you change 45 by 8 degree into radians. You multiply this by pi upon 180. 9 5 is 45, 9 to the 18, 5 1 is 5, 5 4 is 20, that is equals to pi upon 32, that is equals to pi upon 32 radian. Radian is denoted by this to the power c. This is read as pi by 32 radian. Remember that. Radian denoted by c, that is taken by first letter of the word set. I have told you that. Another question. Question. Find the angle between minute hand and hour hand. Minute hand and hour hand. Minute hand and hour hand of a clock at first 4:30 p.m. second 10:40 p.m. So you have to find out the angle between the minute hand and hour hand. So in order to explain that, first of all I am describing a clock to you. This is a clock. Here and here, this is 6 and this is 12. 1 hour, 2 hour, this is 3 hours. This is 2 hour. This is 3, this is 2, and this is 1, this is 4, this is 5, and here is 9, 7, 8, 10, 11, and 12. So I have made this clock. So when your time is 4:30 p.m. So at 4:30 p.m. in this case your minute hand is toward this and your hour hand is between. This is your hour hand. This is your minute hand. For 4 hours 30 minutes, it is necessary that your minute hand is at 6 and your hour hand is between 4 and 5. So, in first case, at 4:30 p.m., angle between minute hand and hour hand is equals to angle made by minute hand minus angle made by hour hand minus angle made by hour hand. You remember that. This is the things. So, as you know, when a minute hand make complete revolution, so time described is 60 minutes. When your minute hand make a complete revolution, in that case, time described is 60 minutes. And when it has made half of the revolution, when minute hand made half of the revolution, it means it reaches to 6. In that case, 60 minutes made 360 degree. So 1 minute made 360 by 60 and therefore 30 minutes. That is equals to 360 by 60 multiplied by 30. So in this way, use that result here. So angle described in 30 minutes. Angle made in 30 minutes minus angle made in 4:30 hours. So in this way, this is equal to 360 multiplied by 30 upon 60 minus, as you know, in 12 hours for our hand. Now for our hand. For our hand, what happens? In 12 hour, angle described is 360 degree. In 1 hour, 360 degree by 12 and 430 hours. 430 hours equal to 430 hours equals to 4.5 hours. That is equal to 9 by 2 hours. So angle describing 9 by 2 hours, that is equal to 360 divided by 12 multiplied by 9 by 2. 30, 15, that is equal to 135 degree. So in this way, angle made in 430 hours, that is equal to 360 divided by 12 multiplied by 9 by 2. And here this will be 180 degree minus, this is 135 degree, this is 135 degree, and your result is 45 degree. So angle between minute and hour hand, you see the calculation, angle between minute and hour hand is 45 degree when the time is 4:30 p.m. Similarly, you calculate the angle between minute and hour hands when your time is 10:40 p.m. Do that. You solve that part yourself. Your answer of this part, I am writing the answer of this part. Your answer is 10 hours 40 minutes 80 degree. Here your 80 degree. Here your 45 degree. These are the answers. You do that. Now another question. Express in circular measure and also in degree measure. Our question is express in circular measure means radian measure. In circular measure, also in radian measure. Sorry, also in degree measure. Circular measure and degree measure. Degree measure of number 1, a regular octagon second, a regular polygon of 40 sides. So now you know that in regular octagon what happens. I am making that regular octagon 1, 2, 3, 4, 5, 6, 7 and 8. This is a regular octagon. So in regular octagon, if it is regular, in that case all the interior angles are equal. In regular polygon, what happens? In regular polygon, interior angles are equal. Interior angles are equal. So now you see that, and when you produce one side of the regular octagon, then what happens? Your sum of this angle and this angle are equal, and another property, second property, sum of exterior angle. Sum of exterior angle is equal to 360 degree. If it is regular, then exterior angles are also equal. Exterior angles are also equal. So means 8 sides implies 360 degree. Then one side implies 360 degree by 8, and that is equals to 45 degree. So this is the degree measure of regular octagon. This is the degree measure of regular octagon. This is degree measure. Now you change this 45 degree into pi radian. You know you have to multiply it by pi upon 180, and this is equal to pi by 4 radian. This is called the circular measure or radian measure. circular measure. Similarly, you can find the interior angles of a polygon of 40 side, regular polygon of 40 side. So, for second part, what will you do? For second part, this is the first part. For second part, 40 sides implies the total measure of exterior angle is 360 degree. 40 sides of a regular polygon implies sum of exterior angle is 360 degree. So in this way, one side implies 360 degree upon 40, that is equals to 9 degree. Now interior angle equals, this is the exterior angle, this is the measure of exterior angle. Now interior angle is equals to 180 degree minus 9 degree, that is equal to 171 degree. This is the degree measure. Now 171 degree is equal to 171 multiplied by pi upon 180. This is equal to 19 pi by 20 radian. This is the circular measure. This is the circular measure. So now you see correction in first part. Correction in first part. Your exterior angle, measure of exterior angle is equal to measure of exterior angle is equal to 45 degree, then measure of interior angle is equal to 180 degree minus 45 degree, that is 135 degree, and this is the degree measure. You remember that. This is the degree measure. Now this is interior angle. Now interior angle in circular measure. Interior angle is equals to 135 degree equals to 135 multiplied by pi upon 180. This is equal to 3 pi by 4. This is the circular measure. You make this correction. That's all. So in this way we can find the circular measure and degree measure of a regular polygon of any side, any number of sides. Now assignment. Assignment. Question number 1. In which quadrant do the following angles lie? Angle lie. Number 1, 60 degree, second 135 degree, third minus 45 degree, and fourth 570 degree. 570 degree. Second question. Find the radian method or circular measure. Circular measure to the following degree measure. To the following degree measure. Number 1, 50 degree, 37 minute and 30 second. Second, minus 22 degree, 30 minute. Third, find the angle between minute hand and hour hand of a clock when the time is 7:20 p.m. Fourth,